So there are many ways and means to counter buffer overflows. The most reliable way is to deal with the programming stage. Here are a few areas that you should consider. Design programs with security in mind. Disable stack execution. This is possible on Solaris. Test and debug the code to find errors and vulnerabilities. Prevent the use of dangerous functions like gets or strcopy, etc. Consider using safer compilers such as StackGuard. Prevent return addresses from being overwritten. Just a few.
And then validate arguments and reduce the amount of code that runs with root privileges. Prevent all sensitive information from being overwritten. Make changes to C itself at the language level to reduce the risk of buffer overflows. Use static or dynamic source code analyzers at the source code level to check the code for buffer overflow problems. Change the compiler options at the compiler level that checks bounds or protects addresses from overriding. Change the rules at the operating system level for which memory pages are allowed to hold executable data. Make use of safe libraries. Make use of tools that can detect buffer overflow vulnerabilities.
Yeah, you can imagine the list goes on and on and on, right? But however, it is strongly recommended that you keep the design of code and test it before it goes live, keeping the security aspects in mind. Always think about security.
Oh, absolutely. When we talk about buffer overflows, data is the main source that is used to attack. That leads us into looking at data execution prevention. You need to make sure that system memory is being used safely and securely. This means monitoring a combination of hardware and software technologies. This technology looks at memory usage and prevents an application from accessing memory that it is not supposed to.
Now, when an exception takes place, hardware-enforced DEP raises an exception, or DEP. You also have software-enforced DEP. Windows uses it to prevent malicious code from taking advantage of exception handling mechanisms. DEP helps in preventing code execution from data pages such as default heap pages, memory pool pages, and various stack pages where code is not executed from the default heap and the stack.